Alright, kites and trapezoids. So this is kind of moving away from the parallelograms into a different type of quadrilateral here. So a kite is defined as a quadrilateral with exactly two pairs of congruent, consecutive, non-parallel sides. That's all of those little words there are important, because in order for a quadrilateral to be a kite, no sides can be parallel and opposite sides cannot be congruent. Okay, so either one of those would disqualify it from being a kite. Now, one of the properties of a kite is that if it is a kite, then its diagonals are perpendicular. Another property is that exactly one pair of opposite angles is congruent. So looking at some problems we have here, we have a kite, NAVY. The measure of angle YNA, so YNA is going to be 54 degrees, and the measure of angle VYX, so VYX, so this little angle right here is 52 degrees, and we want to find each measure. Well, the measure of angle NVY, so NVY, we're going to take this 90 degrees here minus the 52 here, and we get 38 degrees for this one. Then for XYN, so XYN, so this one right here, well, we're going to take, basically what we've got here is we have an isosceles triangle. So we're going to take 180 minus this vertex angle here, the 54 degrees, divide it by 2, and we get 63 degrees. And then finally, NAV is going to be this angle plus this angle, so we get 115. Okay, if that was kind of maybe going a little bit too fast to you, go ahead and maybe pause the video now, go back through until you really understand why those things will work the way they would do, where they worked out the way they did. Bear in mind that all of these angles here around point X are right angles. Now, trapezoid, again, trapezoid should be familiar to y'all from before, but is a quadrilateral with exactly one pair of parallel sides. So the parallel sides are called the bases, the non-parallel sides are the legs. Now, whether something is a base or a leg is totally dependent on whether it's one of the parallel sides or not determined how the trapezoid is turned. Doesn't matter how the trapezoid is turned, what makes a base. A base is one of the parallel sides. And because these two bases are parallel, any of my angles along the leg are supplementary, going back to your same side interior angle stuff. Now, if I've got a trapezoid that has, basically the legs are congruent, that's called an isosceles trapezoid. Think of it basically like an isosceles triangle that got its top lopped off. Okay, isosceles trapezoid theorems. Now, these isosceles trapezoids have some theorems of their own. So first off, if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So angle R is congruent to angle A, angle T is congruent to angle P, kind of like what we were used to with the isosceles triangles. Next, if a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So if you've got a trapezoid and you know that this angle is congruent to this angle, then you have an isosceles trapezoid. Next, if a trapezoid is isosceles, then its diagonals are congruent. And if the diagonals are congruent, then the trapezoid is isosceles. Okay. So we've got an examples here. So find the value of x. Well, I know that because this is isosceles, I know that my base angles are congruent. So I know that, you know, the two obtuse angles are both 140. I know the two acute angles are 5x. And I know that my acute and my obtuse have to add up to 180. So I can set up my equation as 5x is equal to 40, because I know 180 minus 140 is 40, which means that x is going to be 8. All right, my next trapezoid, I have NS is equal to 14, and BA is equal to 25, so I want to find SE. Well, again, I know that my diagonals are congruent, and so this piece here is going to be basically 25 minus 14, which is going to be 11. Now the mid-segment theorem is kind of, again, it's pretty similar to the triangle mid-segment theorem. So mid-segment is going to be joining the midpoints of the two legs, and it's going to be parallel to each base, and it's basically the average of the two bases. So 1/2 the sum of the lengths of the bases, or it's the average of the two bases. So in this case here, I have MY is the mid-segment of the trapezoid OFIG. So if OF is equal to 22 and GI is equal to 30, I want to find MY. So again, basically we're going to find the average. So 22 plus 30 divided by 2, we get 26. Another type of problem you may see is that, well, I've got OF is 16, MY is 18, and I want to find GI. Now, you can do this thing this way, and I've got it set up as the algebraic method. Here's what I find to be a little bit easier. The gap, the distance, or the difference between OF and MY, basically 18 minus 16 is going to be 2. But this thing is halfway between these two. That means that it's also then 2 less than GI. So GI is going to be 18 plus 2, which is going to be 20. Or you can work it out algebraically, whichever. But usually what I find easiest is whatever the gap is between the two, between the base and the mid-segment, either add or subtract that from the mid-segment to find the other base. So we'll see some of those on the examples. Alrighty.